All right, welcome back to day 2 of our journey from zero to data scientist. Yesterday was all about setting the stage, but today is when we roll up our sleeves and get our hands dirty with the one skill you will use in every single project for the rest of your career. Seriously. So let's just dive right in. Okay, first things first, I want you to burn this phrase into your brain. Data ko samajho, tabhi model banao. It means first understand the data, only then build the model. Now, this isn't just some nice quote, it is the golden rule. This one idea is the difference between a project that actually works and one that is a complete and total failure. But why? Why is skipping this step so incredibly dangerous? It's a harsh reality. So many people starting out, they get really excited, right? They download a dataset and they immediately rush to build some fancy, complicated machine learning model. And guess what happens? Almost every single time, it fails. The results are confusing, the model's predictions are garbage, and they have absolutely no idea why. It's because they skipped the one step that matters more than anything else. The answer, my friends, the secret weapon that separates the real pros from the beginners is a skill called EDA. And no, it's not about complex math or super advanced code. It's about something way more fundamental, something more like being a detective. So what on earth is exploratory data analysis? Look, forget the textbook definitions. Think of it like this. You are a detective and your data is a crime scene. EDA is the part where you put on your gloves, you pull out your magnifying glass, and you inspect every single piece of evidence before you even think about naming a suspect. You're basically interviewing your data, asking it to tell you its story, reveal its secrets, and show you all of its hidden flaws. To make this crystal clear, I'm going to tell you a very simple story. And trust me, this one analogy is going to completely change the way you look at data for the rest of your life. Imagine, you walk into a doctor's office and you say, "Doctor, I'm not feeling well." Does the doctor immediately say, "Okay, let's do surgery"? Of course not. That would be insane. First, they do a checkup. They ask you questions, right? Kab se ho raha hai, kya khaya tha? How long has this been happening? What did you eat? Then they check your vitals, your temperature, blood pressure. If they're still not sure, they'll run deeper tests, like a blood test or an X-ray. And only after all of that investigation do they figure out the real problem and decide on a treatment. And that's it. That's the perfect analogy. Your data is the patient. You are the doctor, and exploratory data analysis is the complete health checkup. You would never, ever trust a doctor who gives you medicine without a diagnosis, right? So why would you ever build a model without first understanding your data? It's the exact same thing. Now, I want you to look at this number, 70%. What do you think this represents? The accuracy you need? The chance your project will succeed? Nope. It's something way, way more important about how the pros actually work. 70%. That's the amount of time that senior data scientists at companies like Netflix, Google, and Amazon spend just on understanding their data. Just on EDA. The actual model building, that might only take a few hours. But the investigation, that health checkup, that's where they spend the vast majority of their time. The pros know that the magic is in the diagnosis, not just the surgery. Okay. So I hope you're convinced. You get it. You need to be a data doctor. But the big question is, how? How do you actually perform this checkup? What are the tools inside your medical kit? Well, let's break down the essentials. Here it is, your very first EDA toolkit. Think of DF Head as just your first glance at the patient, just seeing what they look like. DF Info, that's like an X-ray. It helps you find hidden problems, like a broken bone you can't see from the outside. For example, it might show you a price column is secretly stored as text instead of a number, a silent bug that will crash your entire model later. Then we look for missing values. That's like asking the patient, "Hey, did you forget to tell me any important symptoms?" And outliers, those are the really unusual symptoms, like a patient with a super high fever or a customer who suddenly spent $1 million. That's a huge red flag you have to investigate. Now, out of all of these amazing tools, there is one command that is like a magic wand. It is probably the single most powerful, high-impact command that gives you a massive overview with just one simple line of code. And this is it, df.describe. This one command is like getting the patient's full health report printed out instantly. Just look at this. We can immediately start asking smart questions. The average age is about 34, but look, the min and max show our customers are between 18 and 65. Okay, interesting. Now check out average spend. The average is $520 and the max is $980. Not a crazy difference, but what if that max was 50,000? That would be a huge outlier, a major symptom telling us something very strange is happening in our data that we must investigate. You see? This command doesn't just give you numbers, it tells you where to start looking for the real story. But hold on, just knowing the commands isn't enough. It's like a doctor who has a stethoscope but has no idea how to actually use it properly. There are some really common traps that almost every beginner falls into, and avoiding these is what separates a pro from an amateur. Let's look at this, because this is huge. A beginner might just start editing their original data file. A senior data scientist? Never. They always make a copy first, so the original is safe. A beginner might fill in missing money values with the average, but a pro knows that one billionaire can totally mess up the average, so they use the median, which is outlier proof. Beginners always ignore df.info, but seniors know it's the first place to check for those silent, model-killing bugs. And the biggest mistake of all? Skipping EDA to be fast, not realizing that 1 hour spent on EDA now will save them 3 hours of painful debugging later. Guaranteed. And I want you to really get this. Mastering these little fixes, adopting this professional mindset, this isn't just good practice. This is the direct path to thinking, working, and frankly, getting hired like a real data scientist at a top company. This is what they look for. Just pause for a second and think about the shift you've just made. A few minutes ago, you probably saw data as just a boring table of numbers. Now you see it as a patient with a hidden story. You might have thought building models was the main event. Now you know that understanding the data is literally 70% of the job. You might have been confused about where to even begin, and now you have your first professional EDA toolkit. You've just learned the entire philosophy and the practical first steps behind the most critical stage of any data science project. You've learned to think like a data detective, to think like a data doctor. So, now that you know how to diagnose the patient, what's next? Well, tomorrow we prepare for the surgery. I will see you on day 3.